Uh, Welcome to you all for another presentation on compensators. This is one of the very important topic in control system, especially in finding the transfer function of compensators. By the way, what is the compensator? Compensator is a device which can be used in control system in order to improve the system performance. Yeah, welcome to you all for another beautiful presentation on control system subject. In today's presentation, I would like to explain you one of the another important topic, that is on compensators. Basically, compensators are very widely and extensively used in control systems, especially in industrial applications. It can be used very widely. Basically, sometimes any control system, sometimes in order to improve its performance and in its accuracy, we need to give some additional external circuit. Actually, that may be a component or any circuit that can be given externally to a particular control system. That is what a compensator is. Nothing but a electric or electronic circuit that can be given externally or additionally in order to improve the system performance or the system response. Okay, so okay, it has its own merits and then demerits that I can explain you in the subsequent presentations. Okay, so basically these compensator are classified into three broad categories. Those are, one is lead compensator, and second one is lag compensator, and the third one is the lead lag compensators. So in today's presentation, I would like to explain you about the lead compensator. So, okay, so especially as far as our subject is concerned and as far as your academic point of view, and then even in gate examinations also, they will ask you that they will give you the network, and for that you need to identify or to explain the transfer function of that circuits. Means, first of all, you need to know that how the circuit looks like, means how a lead compensator will be looks like, as well as how a lag compensator circuit will looks like, as well as how a lead lag compensator will looks like. And then after that, you need to find out the transfer function. You need to find out the transfer function of each one, and afterwards we will see their merits and then demerits. Okay, in control system application point of view, let us consider the lead compensator. So if you take the circuit, it will be like this only. So there is a resistor R1, and across this capacitor C is connected, and there is a parallel another resistor R2. If you connect any circuit in this connection, it acts as a lead compensator. Okay, lead compensator. So here, if you see here in this particular presentation, I would like to explain you about to find out what is the transfer function of this compensator. So for this compensator, the transfer function is nothing but it is TF is equal to, it is V naught of S by Vi of S. Obviously, you already know about it. This is the basic definition. V naught of S by Vi of S means output by input is nothing but the transfer function. That is what our primary motto of this lead compensator. Okay, so how this transfer function can be obtained? So it will be asked widely in your academic point of view. Those who are okay, academic point of view, it will be very important. Okay, they will ask you to find out the transfer function of lead and then lag and then lead lag compensators, like that. So here, in order to find out the transfer function, let us see here in this circuit. This is the input voltage. Basically, Vi is the input voltage, where this is the current I is flowing here. Actually, because of this Vi of t current, I is flowing from this terminal to, it is entering here. Let us call it as node. Say for example, you can call it as node. At this particular node, your input voltage is Vi of t only here. And from here, if you see this, from here, this particular I will be here. It will be distributed. Means it will be changed as I1, and this is I2. So this particular from this node, so I1 flows through C actually. Similarly, your I2 flows through this R1. Clear? So here I, so from with respect to with respect to or due to Vi of t, your I will be produced, and this I will be it will be distributed at this node as a I1 and then I2. Means I is equal to I1 plus I2, and this I flows through this capacitor and it reaches to this particular node again. It is your I1, reaching for this particular node, and this I2 flowing through R1 and it reaches to this particular node. This is what your I2, and again both currents, your I1 and I2 will combine at this, and then again they will comes out as I and flows through your R2. Therefore, this is what V naught of t. However, this is the voltage across this particular resistor R2. Clear? So it is a very simple actually to find out the transfer function. So here let us see, this is the I1, this is the I2, this is the I. Therefore, at this particular node, if you consider this particular node, if you apply your KCL by using your Kirchhoff current law, what is your Kirchhoff current law? It is I1 or I1 plus I2. Means what is I1? This current. This current I1 is current flowing through capacitor I1, I2 is the current flowing through resistor, and then I is nothing but out. Out means the sum of entering current is equal to sum of leaving current. Therefore, is equal to I. I is nothing but this particular I. Okay, this is what the equation, current equation actually using KCL. Now, what is I1 actually? I1 is nothing but current flowing through the capacitor. So if you see this capacitor, actually it is connected between two nodes, node 1 and then node 2. Let us call it as node 1, otherwise you can call it as node 1, and then here it is, you can call it as node 2. So at node 1 the voltage is Vi of t itself, at node 2 the voltage is V naught of t. Clear? Therefore, if you write the expression for I1, means the current flowing through C, that is nothing but it is C into, it is d by dt of, it is d by dt of Vi of t minus V naught of t. Clear? So C into d by dt of Vi of t, this particular node voltage minus this node voltage. Clear? Means that is Vi of t minus V naught of t. That is what your I1. Plus what is your I2? I2 is nothing but current flowing through this resistor. I is equal to V by R. I is equal to, your I2 is equal to V by R. V nothing but again the same. Vi minus V naught. Vi of t minus V naught of t by this one R1. R1. This is what R1 is equal to what is I? I is nothing but this one. I is equal to V by R here. Here at this particular node, your V nothing but V naught. Means V naught of t by, what is this R? R2. This is what the expression. Now for the second expression, apply the Laplace transformation. Apply the Laplace transformation. Then how it will changes. You apply the Laplace transformation. If you apply the Laplace transformation, and even I can erase this. Clear? I can erase this. Clear? If you apply the Laplace transformation to this expression, it becomes as C into S. Clear? Means differentiation. One differentiation becomes as S. It is Vi of S minus V naught of S. This is already you know very well. Plus 1 by, this is 1 by R1 as constant, into same Vi of S minus V naught of S. This is equal to V naught of S by R2. Clear? Now I can erase this also now. It is not required now. This is not required for me now. Now, from this expression, you segregate both input and then output voltages. So, means that take Vi of S as common, then it is nothing but S into C here, and one more, it is plus 1 by R1. Clear? And there is no Vi of S, only two terms only, Vi of S, Vi of S. Here, V0 of S, V0 of S means Cs into V0 of S, 1 by R1 into V0 of S. So, right side you have V0 of S. Therefore, these two will be also taken on the right side. Then V0 of S you take as common, then you will get it is 1 by R2. Clear? Plus, and then this minus 1 by R1 into V0 of S. Therefore, a minus term, if you take on the right side, it becomes plus. V0 of S will be common. Your 1 by R1 will be there. You will get 1 by R1 here. Similarly, in this case also, V0 of S minus V0 of S into Cs. Therefore, the total term minus V0 of S into C of S will be taken to the right side. V0 of S is common, and plus minus becomes 2, plus if you go take on right side, plus Cs will be there. This implies clear. Now, this implies take the ratio V0 of S by Vi of S, means that V0 of S by Vi of S. Bring this Vi of S here, then this will be here only. Then this comes in the denominator part, means that you have SC plus 1 by R1 by, what is this? 1 by R1 plus 1 by R2 plus S into C. Clear? This is what in general the expression basically, and furtherly this can be simplified in another simplest form. Actually, we will see that also. This is what actually your transfer function, but you can simplify a little bit more simplified way. So what can be done for this? So further simplification. So from this you can write that V0 of S by Vi of S is equal to, then take cross multiplication. So then here if you simplify, what you will get, R1 into SC R1 plus 1 means you can write 1 plus SC R1. Can you write like that? 1 plus SC R1 by your R1 will be there in, this is what, if you simplify this part, R1 will be comes like this, by whole by means this by this particular. Okay, then simplify this also. If you take LCM here, R1 R2 will be there in denominator part here. R1 R2 comes in denominator. Then here if you simplify this, obviously here you will get R2, here you will get R1, means in order I will write R1 plus R2 plus what is this? R1 R2 SC, means your SC multiplied with R1 R2. Clear? So getting no? Therefore, now I erase this particular, now this is not required actually. And further what I need to know from this sort of numerator, and for this I can simplify this as 1 plus SC R1 by R1, let it be like that, and then you take this to the upside, means to numerator part, then this particular denominator will be reversed, means R1 R2 will go into upper, and your R1 plus R2 plus S into C R1 R2 will be there in denominator. Here this R1 will be cancelled out. What remains here? It is R2 into 1 plus S into C R1 by this total R1 plus R2 plus S into C R1 R2. Clear? This is what remains actually after the simplification. Then little bit, one or otherwise in 2 more steps your answer will be, you will get your answers. Now we are reaching to your answer, and finally what I will write, it is 1 plus SCR1 into bracket, and furtherly, if you further simplify this, R2 plus multiply with inside this R2 plus 1 into R2 into 1 R2 plus again you multiply that SC R1 R2, you can write like that, R1 and then R2. Clear? By, and then it is same, R1 plus R2 plus S into C R1 R2. Clear? This is what your expression now. And now what I can do, a small thing I can do here. I want to do small further this thing. So in this, what I can do, C R1 R2. C R1 R2 in numerator and denominator I can take as common. C R1 R2, if you take as common C R1 R2 in denominator, it is S plus R2 by what it comes, C, what will come, C R1 R2, no, C R1 basically, CR1 only, because CR1 R2, because if you multiply with this, what you will get, CR1 R2 also, no, clear? Yes, C into R1 R2 definitely, because CR1 R2, S will be common only, R2 will be there, and your C R1 R2 will be there. If you multiply, R2 will remains there. Clear? And then by here what you will get, C R1 R2 take as common. Here also you will have S plus R1 plus R2, R1 plus R2 by C into R1 R2 will come here. Then these two will be cancelled out. Both will be cancelled out there. Clear? Both will be out there. Then what will you have actually? Then I will write here. And the next step I will write here. There you can write again, if you see here, this R2 will be cancelled out. Then what will remains there? This will be out. S plus what you will have in numerator? S plus 1 by CR1. Is it not? 1 plus S plus 1 by CR1 you will have here. By means this one. S plus what you will have? R1 plus R2 by C into R1 into R2. For this, what I can write, just I will write for you just to see. A small thing actually. S plus what you will have here? I will write as it is R1 R2 R1 plus R2 by what is there? C into R1 R2 is there, no? This is what the product. So I do a small thing for you actually. What is that, So this is nothing but this I can write. It is S plus 1 by CR1. For that I don't want to change, that I will write as it is. Here S plus let us see let us carefully see here, R1 plus R2 by R2, because CR1 is there here, again CR1 is there here, therefore CR1 is required because it is a time constant for R1C circuit. If you see that lead compensator, R1 parallel with C, R1C, therefore this CR1 is there, CR1 is there, therefore R1 plus R2 by R2, this particular portion, this one, that you consider as okay. If you consider that, and it is 1 by CR1, means that what I can write, I can write like this, 1 by R2 by R1 plus R2 into C into R1. Can I write like that? Can I write like this for this? 1 by. So if you take upper side, again if you change this, again it will be like this only, R1 plus R2 by R2. It will be, this particular will be converted like this only. Therefore, here what I want to take as, this is something I want to consider as some alpha. If you write this particular R2 by R1 plus R2 as alpha actually, what I want to, that is some alpha basically, means that this is what S plus, and finally what I want to write is V naught of S by Vi of s is equal to s plus 1 by the CR1 you can consider as some t, s plus 1 by t by s plus 1 by alpha times t. This is the very standard form of transfer function of compensator. This is the final form actually. S plus 1 by t by s plus 1 by alpha t. What is t here? T is the time constant, that is c into r1. What is alpha? Alpha is nothing but r2 by r1 plus r2. This is what your alpha, and obviously t is nothing but same as your c into r1. This is what your final expression of the transfer function, right? So with this we'll finish off this presentation here, and in further explanation we will see in the next subsequent presentation, right? See you, we'll meet in the next presentation. All okay.